Hello, my name is Jesus Rivas. I'm going to present the black box testing. As we reviewed in the last section, we can have black box or white box. The difference is that in the black box, we didn't know, we don't know how the inputs are processed. We only care about the outputs that we're going to have. So the three tests that I'm going to present are the boundary value, decision table, and finite state machine testing. Okay. So the boundary value testing, the purpose is verify the behavior of the system at operating extremes or at the boundary that we have. And we're going to do that because the system tends to fail in this boundary with this value nearest to the last value that we can have. Some of the applications are in software or software components, so I think we can use this kind of test for our final project that is basically a software. So the first step to perform this test is by identifying equivalent classes. And what I mean is we must define which are our boundaries. For example, in the upper right side of the slide, we can see that we have a valid values that are in green, 1 to 1000, and some invalid 0 or less, or maybe 1000 or more. So we can translate these to our project by, for example, the number of users that the system support, and that could be a valid portion. Another way to identify the equivalent classes are by defining the specific value that most we have. For example, in the project of the drone, we can say that the total weight of the drone must be less than 1 kilogram. So this would be another clause. And the last way is by specifying specific values. Or, for example, in the in our final project, we can say that the system uh, has a compatibility with these two versions of the Android. So we are defining specific versions. So once we have these, now we can do the test cases. And basically, we are going to put values to see how the system reacts. For example, in the number of users, we say that 1 to 1000 is a valid um, a valid number. So we're going to put maybe 0, maybe 1002, and see if the system stops or maybe continue working, or see what happens. Another way is with the weight of the drone, also by uh, defining values like 0.99 or 1.12 or something like that. And it's the same logic for the Android versions. So let's see what happened with the system if we put the next version to the one that we're going to use. So this is the way that the boundary value testing looks like. So the next one is the decision table. And here, basically, we're going to model the logical behavior of our system by describing the conditions that we can have and action that must be performed once specific conditions are met. Okay, so the method is, as I said, is identify all the possible conditions and combination that could affect the behavior of our system. In this example, um, we can test the access to our system. To access our system, we need a user, we need a password, and we need to be registered in the database. So here we have conditions that are we can request login, um, valid name, valid password. We have actions like offer recovery credentials, activate entry box username or password, or enter to the system, give access. We have the zero, that means the false or true. In this case, zero is false, one is true, and the x the value is not registered. Um, Also, we have TC1, TC2, 3, TC4, and it's like the rule that must be um, performed or must be uh, addressed to have a specific action. And for example, if someone requests a login, it's true. We have one in TC4, and that person puts a valid username. Then we have one, two, and then the password is valid. So we have three ones that uh, complete the rule to the specific action that is entered to the system. So this is the way we can test if the systems acts like the decision table to see all the possible combinations. Okay. The next uh, method is the finite state machine testing, and this is to evaluate the execution of control functions, and it is used to model dynamic behavior of complex systems. And I have an example here that is not that complex. So we have to define the three sections to do these tests. That are states, that are activities or wait from some event, then the transitions we have between the states that we have, and events or inputs that um, must be uh, must be put in the system to have a specific transition. And here we have a simple door. The two states that we can have in the door are closed or open. And we have the transition that is closed to open and open to close, as we can see here. And we have entry actions that are basically the events or inputs. So one event could be is if someone pull the door. If someone pull the door and that person meet the condition, and we will have the transition. If the door was closed, then it will be open. So this is the way we can model the behavior of our system. And some of the strategies that we can follow are see the transition through all the states, or maybe transition through all the state event combinations, or maybe we can put a wrong event and see what happened with the system. So basically, those are the tests that I'm going to review. So thank you for your time.